I'm Todd Jensen. I'm the general manager here at Smith Metal Products, and right now I'd like to show you our 3D printing capabilities. Here at Smith Metals, we're using our 3D printer as a means to prototype metal injection molded components. So what we're doing here is we're actually creating a MIM-like part with this 3D printer. And the way we do it is one layer at a time. In this printer, we'll show you that we lay down a layer of fine metal powder, and that metal powder could be any alloy. It could be a 316 stainless steel, it could be a 4140 carbon steel. But what we do is this printer will lay down a very thin layer of metal powder, and then it will lay down binder in the shape of 1/2000th of an inch cross section. And it will do this over and over and over again until the green part is built up to be a MIM-like printed part. And this here is an example of the green printed part. You can see it's one end of a tiny pipe wrench, and this is currently in its green state, in its fragile state. So what will happen is this part will then go through a curing process to harden the binder so that it's handleable, and then it will go out to our debinding and sintering furnaces, where it will run through debinding, where we remove that binder that was placed in the powder during printing, and then it will be exposed to high temperatures, roughly 1380 degrees C, and that will cause these metal powder particles to bond and shrink down to a fully dense metal part. So here in my hand you can see the green printed part, and then here's the sintered part, which is nearly fully dense. And once again, what we're doing this for is to create a prototype, quick turn prototype for our customers, so that they can gain confidence in their part design or the ability for a MIM part to work in their application. They can do all of this without purchasing a mold, which could be very costly. So we're very excited about this capability. We chose to use the binder jetting process, and I'm going to show you exactly what that is a little bit more closely right now. Okay, so as I mentioned before, what's happening here is we're laying down a very thin layer of powder. You can see the roller is rolling this metal powder across the top of the build box, and then as soon as that is completed, what you'll see is the print head will come across, and it's going to print one small section of the parts that are in the current build box. So as the print head goes back and forth, you'll be able to see the binder droplets are laid down over the section of those parts. It's creating the part one layer at a time. And in this particular build, there's actually 8 parts that are in this build box. Now, what's going to happen here now is the box will drop, the platen will drop down, and this hopper comes across, and it is drying that layer of binder with this heat lamp. It's drying that layer of binder in the powder, and now it just laid down another very fine layer of metal powder. This happens to be a 316 powder, and the roller behind it is smoothing that out to a very uniform layer. Now I'm going to direct you over to the screen here. You can see here virtually the virtual build box, and the blue highlighted areas are the cross section that is currently being built. So you can see here, anything below this blue cross section is already built. That's down in the build box, and whatever is above the blue cross section has yet to be built. In the end, this build box will be full of powder and printed parts prior to the sintering process. So that is an overview of our 3D printing capabilities. We're very excited about this, and we think that it's going to give our customers another nice service that we can provide to them to help them solidify their designs. Thank you.